There are lots of different ways to think about differential equations, and one of the nicest, I think, interpretations of a first-order differential equation is as something known as a slope field. So what I want to do is show you what a slope field is and how to think about a differential equation that way. So say you have a differential equation for an unknown function y of t. If you have the differential equation y prime equals f of ty, think about this just in terms of what you learned from calculus class. Y prime means a slope, and therefore the thing on the right-hand side, the f of ty, is just a rule for what the slope is for any value of t and y. It's just a rule for the slope, and that's a simple but really powerful idea. So let's do the following thought experiment. Suppose that I told you I was going to tell you the slope of the function y of t at just a few points. I'm just going to tell you at a few points what the slope is, and that's all the information I'm going to give you. And I'm going to represent that slope by a tiny little line segment that goes in the direction of the slope, something like this. So again, it's important to understand this is not a dotted curve that I've drawn for you. I've told you the slope at various different points. And now suppose I asked you to actually draw in what is the unknown function. You'd say that's easy. It just has to be the curve that kind of passes through all of these things. That's the only way it has the right slope at every point. And I say, exactly. That's exactly right. So the idea now is that if you have a differential equation, you can use that rule on the right-hand side of your first order ODE to actually get those little line segments. So let's do an example. So dy dt equals t minus y squared is going to be our differential equation. And let's just figure out the slope at a particular point. I'm going to choose t equals 0, y equals 0. And remember, t is the independent variable and y is the dependent variable, but we're just going to pretend for now that we can choose whatever values of each of those things that we want. Okay? So y prime is going to be t minus y squared. That's 0 minus 0 squared. That's 0. At 1, 0, when t is 1 and y equals 0, y prime is 1 minus 0 squared, that's 1. You can keep playing this game with any point you want. At 3, 2, y prime is 3 minus 2 squared, that's minus 1. So suppose you did this for every point you could think of, and then you drew all that information. You might get something like this. I'm just doing this very roughly by hand, but you would plot a whole bunch of different slopes at different points. And this is called the slope field, or sometimes you'll hear it referred to as a direction field, okay, but it's always the same thing. And suppose now you want to be able to visualize or to find the unknown function. Well, one thing you need to know is you need to know where to start. So suppose we specify an initial condition at y of 0 equals 0. Then what we would do is we'd start here at 0, 0. The slope here turns out to be 0. I follow all the slopes and I see what kind of curve I come out with. Now, of course, this is really hopefully a simple idea, but it's a pain to do by hand. So the way we generally do this is with software, and it's important for you to practice doing this using software, but I wanted to show you the basic idea on pencil and paper.